In this video, we're going to talk about the power rule. The power rule is the rule that tells you how to take the derivative of a power function without resorting to the actual definition of the derivative. So the statement of the power rule, remember a power function is a function that looks like x to some number power, right? And so here is the power rule. It says if f of x is equal to x to the n power. In other words, if f is a power function, then its derivative is n times x to the n minus 1. So you can see all you really have to do is to move the old power down out in front and then subtract 1 from the old power to get the new power here. Okay, so that's it. So that's a pretty nice form, pretty straightforward operation if you have the function written in the power function format here. All right, so let's take a look at some examples. All right, in the first example, it's pretty easy, right? We have x to the 5th power, and that is a power function, right? It's x to some number power, so we can use the power rule to take the derivative. All right, so we have x to the 5th power, and what we're going to do is to bring the old power down, right? So this 5 that was up in the exponent will come out in front, and then we're going to subtract 1 from the power, so 5 minus 1. And of course, you can simplify that to 5x to the 4th power. So the derivative of x to the 5th is the function 5x to the 4th power. All right, so pretty straightforward. Let's take a look at example 2. It's slightly more complicated. Here I have f of x equals 1 over x. Okay. So at first that doesn't really look like a power function, but if you recall from the video about power functions, right, I can use just a little algebra to rewrite that function as a power function. So 1 over x, right, is the same as the function of x to the minus 1 power. Okay, if you're confused about that, then go back and watch the video about power functions and the fact from algebra that allows us to do that. Okay, so notice no calculus was done here. This is just algebra getting from here to here. But now we're ready. We know now that this is a power function, right? And we have it in the exact format that we need, right? X to some number power. So we can apply the power rule. So the power rule says take the old power and bring it down out in front, which we did, right? And then to get the new power, you would just take the old power and subtract 1. And of course, we can simplify that. We have negative x to the minus 2, right? Just simplifying that out, and that is the derivative of the function 1 over x. You could also use the rules of algebra to switch this back into a fraction like this. It would be negative 1 over x squared, right, if you did that. But at this point, it's not really totally necessary to do that. Later on, when we will use these derivatives to solve other problems, then you probably want to go ahead and do that. But for right now, we are just practicing computing derivatives. So for right now, just leave these negative exponents there in your answer. All right, let's take a look at another example. So here we have a more complicated function, f of x equals x squared divided by the 5th root of x to the 4th. Okay, so the very first thing that I'm going to do is to rewrite that radical here in the fractional exponent notation. So anytime you're taking the derivative, it's just going to be a lot more useful to have any radicals changed over to the fractional exponent notation. And the reason for that is so that we can use the power rule to take the derivative. Okay, so so now the function will look like x squared over x to the 4/5. And here we are dividing like some like bases, right? On the top we have x squared, and the bottom we have x to the 4/5. So you have to remember how that works, right? From the rules of algebra, we would know that, hey, when you are dividing like bases, what do you do with the exponents? You subtract them, right? So x squared divided by x to the 4/5 is the same as x to the 2 minus 4/5. Okay, So now we will actually go ahead and subtract 4/5 from 2. 2 minus 4/5 comes out to be 6/5, right? By getting a common denominator, 2 is equal to 10/5, right? And then 10 minus 4 will be 6 up here. Okay. So again, notice no calculus took place here. All we are doing is using the basic rules of algebra, right, to rewrite this function in the power function format. And now we can see that this is definitely a power function. It is x to some number power, and that's the format that we really need that in to take the derivative. Okay, so now we are ready to use the power rule. I'm going to bring down the 6/5 out in front. I generally like to bring it just out in front of the x there when it's a fraction. It just looks better to me, although you don't have to write it that way. And sometimes you might see it written in other ways. All right, next then we need to subtract 1 from the exponent. Okay, and so 6/5 minus 1. 1 is 5/5, getting a common denominator, so 6/5 minus 5/5 will come out to be 1/5. So the derivative of this function here is 6/5 times x to the 1/5 power.